We have spent more than 60 years and billions of dollars pointing the most sensitive instruments ever built at the sky. The goal was simple. Find one confirmed signal from another civilization and change everything we know about our place in the universe. We expected that in a cosmos this large, with 2 trillion galaxies and more stars than grains of sand on every beach on Earth, finding someone else would just be a matter of patience. We thought the universe would be crowded, but that is not what happened. 60 years of scanning, millions of frequencies, 100 of the nearest galaxies, thousands of the nearest stars, and what we found was silence. Total, absolute, suffocating silence. Not a whisper, not a pulse, not a single confirmed pattern that could be attributed to anything other than nature doing what nature does. Frank Drake pointed a telescope at 2 stars in 1960 and heard nothing. Paul Horowitz scanned 8.4 million channels at Harvard and heard nothing. The breakthrough. Listen Initiative spent $100 million and dedicated time on 3 of the world's most powerful telescopes and heard nothing. In 2020, a team at the University of Manchester analyzed data from the Parkes telescope looking at 10.6 million stars in the plane of the Milky Way. They found no evidence of extraterrestrial technology. Not in any band, not at any frequency, not at any distance. The universe is quiet, disturbingly quiet. And for decades, that silence was treated as a problem to be solved. Maybe we were not looking hard enough. Maybe our instruments were not sensitive enough. Maybe they were out there, and we just had not found the right channel yet. But in the last 10 years, something shifted. A new generation of scientists stopped asking, "Where is everyone?" and started asking a different question. A question that no one in the room was quite prepared for. What if we are not the ones looking for aliens? What if we are the aliens someone else is looking for? That is not a thought experiment. That is not philosophical speculation over coffee. That is a question that real scientists at real institutions have started to formalize. And the evidence they are assembling does not look like fringe theory. It looks like a mirror. We are going to look at 8 pieces of evidence that suggest the most detectable, the most anomalous, the most obviously alien thing in this region of the galaxy is not hiding behind a distant star. It is sitting on the 3rd rock from a yellow dwarf in the Orion arm of the Milky Way. It is broadcasting. It has been broadcasting for over a century, and it has been biologically visible for more than 2 billion years. You are the signal. You just have never thought to look at yourself that way. Let us start with why this matters. For most of the history of SETI, the assumption was that the universe should be teeming with life. In 1961, astronomer Frank Drake sat down at a blackboard in Green Bank, West Virginia, and wrote an equation. It was a way to estimate the number of detectable civilizations in the Milky Way. You take the rate of star formation, multiply by the fraction of stars with planets, multiply by the fraction of planets that could support life, multiply by the fraction where life actually develops, then intelligence develops, then technology develops, and finally, by how long those civilizations last. When Drake first ran the numbers, even with conservative estimates, the equation produced results in the thousands. Thousands of civilizations in our galaxy alone, right now, potentially transmitting. The Kepler Space Telescope and the James Webb Telescope have since filled in some of the blanks. Planets are everywhere. Rocky planets in habitable zones are not rare. And the numbers have only gotten more optimistic. By most modern estimates, there should be somewhere between thousands and millions of civilizations in the Milky Way. And yet, we hear nothing. That gap between what the math says should be there and what we actually find is the Fermi paradox, named after physicist Enrico Fermi, who supposedly asked the question over lunch at Los Alamos in 1950. Where is everybody? For 75 years, every answer to that question has assumed that the problem is with them. They are too far away. They are hiding. They self-destructed. They are using communication methods we cannot detect. The explanations always point outward. Nobody pointed the telescope around. Nobody asked, what if the most interesting thing in this data set is not what is missing, but what is already here? Let us start with the most literal version of this idea, the one you can measure. In 1901, Guglielmo Marconi sent the first transatlantic radio transmission. A simple sequence of Morse code tapped out and beamed across the Atlantic Ocean. It was meant for a receiver in Newfoundland. But radio waves do not stop at their intended destination. They keep going. They travel at the speed of light, and unless something absorbs them, they travel forever. That signal from 1901 is still moving. Right now, as you listen to this, that transmission is roughly 125 light years from Earth. It has already passed more than 100,000 stars. And it was followed by everything else we have ever broadcast. Every AM radio station, every FM frequency, every television signal, every military radar ping, every satellite uplink and downlink, all of it radiating outward into space at the speed of light, expanding in every direction simultaneously, forming a sphere of electromagnetic noise centered on Earth. Scientists call it the radio bubble. And as of right now, in 2026, that bubble has a diameter of roughly 250 light years. That is a tiny fraction of the Milky Way, which stretches about 100,000 light years across. But it is not nothing. Inside that bubble, according to a study by Lisa Kaltenegger and Jackie Faherty, published in Nature in 2021, at least 2,034 star systems have been in the right position to detect Earth. Not hypothetically, not theoretically. They mapped the positions and motions of those stars using data from the European Space Agency's Gaia Observatory. They found that 1,715 of those stars were in position to have spotted us since the beginning of human civilization 5,000 years ago. And 75 of those stars entered the detection window in the last century, right as we started broadcasting. Think about that for a second. We did not send a message. We did not compose a signal. We just turned on the radio. And from that moment, we became visible. Not visible the way a planet is visible, a dim speck of reflected light. Visible the way a bonfire is visible in a dark forest. Something that does not belong, something artificial, something that screams, "This is not natural." And here is the part that makes this more than a fun thought experiment. Our radio bubble is the least interesting thing about us. It is the newest thing, the quietest thing. We have been visible for far, far longer than 100 years. But before we get there, you need to understand something about how we look for life on other planets. Because it turns out, the method we use to search for aliens is the exact same method that would find us. This brings us to the first piece of evidence. And it is the oldest one. Evidence 1, the oxygen anomaly. Your atmosphere has been screaming for 2.4 billion years. If you pointed a telescope at Earth from another star system, the single most obvious thing about our planet would not be the radio signals. It would not be the city lights. It would not be any sign of technology at all. It would be the oxygen. Earth's atmosphere is roughly 21% oxygen. That number probably does not sound strange to you because you breathe it every day. But from an astrophysics perspective, it is one of the most anomalous things in the known universe. Oxygen is reactive, ferociously reactive. It bonds with almost everything it touches. It rusts iron, it burns wood, it oxidizes rock. Left to its own devices, free oxygen in a planetary atmosphere should disappear within a few million years, consumed by the geological and chemical processes of the planet. Think of it like a bathtub with the drain open. If nobody is running the tap, the water drains out. The fact that Earth's bathtub has been full for over 2 billion years means someone has been running the tap non-stop for longer than complex animals have existed. That someone is life. Specifically, photosynthetic life. Cyanobacteria, algae, plants. Organisms that take in carbon dioxide and water, use sunlight to break them apart, and release oxygen as a waste product. The Great Oxidation Event, which occurred approximately 2.4 billion years ago, marks the moment when these organisms had produced enough oxygen to permanently alter Earth's atmosphere. Before that event, Earth's air was a mix of nitrogen, carbon dioxide, methane, and trace gases. Not much different from Mars or Venus. After it, the atmosphere became something entirely different. Something that would register as immediately anomalous to any observatory capable of reading atmospheric chemistry at interstellar distances. And here is why this matters for you, sitting right here. The James Webb Space Telescope is doing exactly this right now. It is reading the atmospheric chemistry of exoplanets, planets orbiting other stars, by analyzing the light that filters through their atmospheres as they pass in front of their host star. This technique is called transmission spectroscopy. Think of it like holding a glass of wine up to a lamp. The color of the light that passes through tells you what is in the glass. Same principle, except the glass is a planet's atmosphere and the lamp is a star. When astrobiologists talk about biosignatures, signs of life detectable from a distance, oxygen is the gold standard. A 2018 review paper led by Victoria Meadows at the University of Washington, published in the journal Astrobiology, laid out the case in detail. There is no known natural process that can sustain high concentrations of free oxygen in a planetary atmosphere over geological timescales without biological replenishment. Volcanoes cannot do it. Photochemistry can produce small amounts, but nothing close to 21%, and not for billions of years. If you see persistent oxygen in an atmosphere, something alive is almost certainly producing it. Earth has had that signature for 2.4 billion years. We have been searching for biosignatures on other planets for barely 2 decades. That is a ratio of 125 million to 1. Any civilization within range that developed atmospheric spectroscopy at any point in the last 2 billion years would have flagged Earth immediately. Not as a candidate, not as a maybe, as a confirmed anomaly. A planet with an atmosphere that should not exist unless something is alive on its surface. And it gets stranger. Because oxygen alone is interesting. But oxygen combined with methane is a red alarm. Methane and oxygen should not coexist in an atmosphere. They react with each other. In chemical terms, they are thermodynamically unstable together. Over time, one should consume the other until only one remains. The fact that Earth has both simultaneously in significant quantities means something is constantly replenishing both gases at the same time. On Earth, that something is biology. Plants and cyanobacteria produce the oxygen. Methanogens, ancient microorganisms in swamps and ocean floors and the guts of animals, produce the methane. The coexistence of these two gases in thermodynamic disequilibrium is, according to James Lovelock and Diane Hitchcock's original 1967 paper, the clearest possible chemical indication that a planet is alive. Think about what this means for you. You are walking around on the surface of a planet that has been biochemically screaming into the void for longer than complex animals have existed. Longer than fish. Longer than dinosaurs. Longer than anything with a spine. Your planet has been advertising the presence of life since before there were eyes to see it. And it is not a subtle advertisement. Earth's oxygen-methane disequilibrium is so extreme that a 2022 paper in the Proceedings of the National Academy of Sciences modeled what the Great Oxidation Event would have looked like from an interstellar distance. The conclusion was stark. The transition from an anoxic to an oxygenated atmosphere produces a spectral change that would be detectable by any telescope roughly as capable as the ones we are building right now. Not in theory. In practice, with achievable technology. Let me put this in personal terms. You are sitting in a room right now. The air you are breathing contains molecules that would set off an alarm on any exoplanet survey in the galaxy. The atmosphere wrapping around the building you are in, the car you drove today, the park you walked through, every cubic meter of air on this entire planet is chemically impossible without life. You are breathing the evidence, and the universe has had 2.4 billion years to notice. That is not a number you can wrap your mind around easily. Let me try. If you compressed Earth's entire history into a single 24-hour day, with the planet forming at midnight and the present moment at the end of the day, the Great Oxidation Event happened around noon. We have been biochemically visible for half of Earth's entire existence. Human civilization, by comparison, occupies the last fraction of a second before midnight. We showed up at the party with 12 hours left in the show already running. The question is not whether anyone has noticed. The question is whether anyone has been watching for the entire performance. And if they have, what they have concluded about the organism that just appeared in the final second and started rearranging the furniture. But here is where it gets worse, because the atmosphere is just the start. Evidence 2. The Murchison meteorite and the building blocks that came from somewhere else. On September 28, 1969, a fireball broke apart over the town of Murchison in southeastern Australia. Fragments of a meteorite, roughly 100 kilograms of dark carbon-rich rock, scattered across the surrounding farmland. Local residents collected pieces immediately, and scientists secured samples within days. This was fortunate because the Murchison meteorite would become one of the most studied objects in the history of science. When researchers cracked those rocks open in the laboratory, they found something that reshaped the entire field of astrobiology. Inside the meteorite were organic molecules, not one or two. Over 86 different amino acids have been identified in Murchison to date, according to analyses published in scientific reports. Amino acids are the building blocks of proteins, and proteins are the machinery of every living thing on this planet. Some of the amino acids found in Murchison are identical to the ones your cells use right now: glycine, alanine, glutamic acid. Others are amino acids that do not appear in any living system on Earth. They were formed in space, through chemistry that has nothing to do with biology, on the parent body of that meteorite more than 4 billion years ago. And it was not just amino acids. In 2010, a team led by Philippe Schmidt-Koplin at the Helmholtz Center in Munich used ultra-high-resolution mass spectrometry to analyze the full chemical complexity of the Murchison meteorite. They found over 14,000 unique molecular compositions. 14,000. And they estimated that the true number, accounting for the limitations of their instruments, could be 50,000 or more. That is more molecular diversity than has been found in any petroleum sample on Earth. A rock from space, formed before our planet existed, carrying a chemical library more complex than anything our planet's geology has produced on its own. Think about that. A piece of the early solar system, a fragment of something that was circling the sun before Earth had cooled, contained more distinct organic compounds than we find in the most chemically rich environments on our own planet. The universe was doing organic chemistry at a level of complexity that we are still cataloging more than 50 years after the meteorite landed. But Murchison was just the beginning. In 2014, the Japan Aerospace Exploration Agency launched the Hayabusa 2 spacecraft on a 300 million kilometer journey to an asteroid named Ryugu. This is a carbon-rich, diamond-shaped space rock roughly 900 meters wide that orbits the Sun between Earth and Mars. Hayabusa 2 successfully collected 2 samples directly from the asteroid's surface, one from a natural site and one from an artificial crater it created by firing a copper impactor into the surface. It sealed those samples in airtight capsules, flew them back to Earth, and dropped them in the Australian outback in December 2020. And in March 2026, a team led by biogeochemist Toshiki Koga at the Japan Agency for Marine Earth Science and Technology published the results of their analysis in Nature Astronomy. What they found? stopped conversations in laboratories around the world. All 5 canonical nucleobases: adenine, guanine, cytosine, thymine, uracil. In roughly equal proportions. Those are not just organic molecules. Those are the chemical letters that spell out DNA and RNA. They are the alphabet of the genetic code. Every instruction your body has ever followed, from the moment you were a single fertilized cell to right now as your neurons fire and your heart beats, is written in those 5 letters. And they found them on an asteroid, sealed in a capsule that had never touched Earth's atmosphere, with no possibility of contamination. Think about the logic here. The building blocks of your genetic code exist on space rocks floating through the solar system. They are not unique to Earth. They are not the product of some special chemistry that only happens here. They appear to be a standard feature of the early solar system, baked into the same molecular clouds that collapsed to form the Sun and the planets 4.6 billion years ago. The same building blocks had previously been found in the Murchison meteorite. They were found in samples from asteroid Bennu, returned by NASA's OSIRIS-REx mission. They were found in the Orgueil meteorite, collected in France in 1864. Every time we crack open a carbon-rich space rock, we find the chemistry of life already there. This does not prove that life on Earth came from space, but it proves something almost as strange. The raw ingredients for life are not rare. They are everywhere. They have been riding around on asteroids and comets for billions of years, crashing into planets, seeding surfaces with organic chemistry. And that means Earth is not a sealed box where life spontaneously appeared from nothing. Earth is a planet that was showered with the ingredients for life from the very beginning, like a kitchen that came pre-stocked before anyone moved in. Now, think about what that looks like from the outside. An alien scientist studying our solar system would find nucleobases and amino acids on asteroids. They would find the same molecules in comets. And then they would look at the third planet from the Sun and find those exact molecules organized into self-replicating structures that have been running continuously for 3.8 billion years. Every other body in the system has the raw ingredients. Only one body assembled them into something alive. We are the anomaly in our own solar system. We are what happened when the chemistry worked. And that raises a question that most people skip right past, but that sits at the center of everything. Why here? If the ingredients are everywhere, why did only one planet assemble them into life? The standard answer is conditions. Earth had liquid water. Earth had a magnetic field to shield it from solar radiation. Earth had plate tectonics to recycle nutrients. Earth sat in the habitable zone of a stable, long-lived star. All of those things are true. But they are also true, to varying degrees, of other bodies in our solar system. Europa, one of Jupiter's moons, has a liquid ocean under its ice crust. Enceladus, a moon of Saturn, has hydrothermal vents on its ocean floor, the same kind of environment where life may have first appeared on Earth. Mars had liquid water on its surface for hundreds of millions of years. And yet, as far as we can tell, None of them produced life. The ingredients were there. The conditions were at least partially right. And life did not arise. Not on Mars, not on Europa, not anywhere else we have looked. Which means one of two things. Either life is so improbable that even having all the right ingredients and reasonable conditions is not enough. Or something happened on Earth, some specific event, some particular sequence of chemical reactions, some lucky accident that did not happen anywhere else in the solar system. And that event produced a chain reaction that has been running for 3.8 billion years without stopping. Either way, Earth is not ordinary. Earth is the place where the most improbable thing in the solar system happened. And the evidence of that event is on display. In the atmosphere, in the oceans, in the soil, in the chemistry of every asteroid that shares our system. From the outside, we are not one of many. We are the one. And the timing of it makes the anomaly even sharper. Life appeared on Earth roughly 3.8 billion years ago. The planet itself is only about 4.5 billion years old. That means complex organic chemistry crossed the line into self-replication within roughly 700 million years of the planet forming. In geological time, that is fast, suspiciously fast. The planet was still being hammered by asteroids, still cooling from a molten state, still developing its first stable oceans, and somehow life showed up almost the second conditions allowed it. Biologists have debated what this timing means for decades. Some argue it suggests abiogenesis. The transition from chemistry to biology is easy. If life appeared quickly on Earth, maybe it appears quickly everywhere conditions are right. But if that is true, then the silence of the galaxy becomes even harder to explain. If life is easy, where is everyone? Others argue the opposite. Maybe life appeared quickly on Earth because the ingredients were already assembled. Not on Earth, but on the asteroids that delivered them. Maybe the nucleobases and amino acids on the Murchison meteorite and on Ryugu were not just raw materials. Maybe they were already organized into something more complex. Pre-biological systems that were one step away from self-replication, needing only the right liquid environment to cross the final threshold. If that is the case, then Earth did not independently invent life. Earth provided the petri dish. The experiment was already running when the dish arrived. And the experiment worked exactly once, on exactly one planet, and produced a chain reaction that has been running for 3.8 billion years without a single interruption. Think about that number. 3.8 billion years. Without stopping, without a reset, without a single moment when the chain of life was broken. Through ice ages that froze the planet from pole to pole, through asteroid impacts that killed 90% of all species, through volcanic events that blanketed the sky in ash for centuries. Life did not just start on Earth. It refused to stop. And that refusal, that relentless persistence, is itself a signal. Because a planet that has maintained continuous biological activity for 3.8 billion years is not just alive. It is stubbornly, improbably, defiantly alive. And that stubbornness is written in the atmospheric data for anyone to read. We are not just the planet where chemistry became biology. We are the planet where biology survived everything the universe threw at it for nearly 4 billion years. That is not ordinary. That is not expected. That is the most persistent anomaly in the solar system. And if you think that is where it stops, it does not. Because what we did next has no precedent anywhere in the known universe. Evidence 3. The technological fingerprint. We are chemically altering our own planet in ways visible from light years away. There is a category of detection that astrobiologists call technosignatures. These are signs not just of life, but of technology, of a civilization that is actively modifying its environment in ways that cannot be explained by natural processes or by biology alone. And when scientists sat down to catalog what Earth's technosignatures actually look like from a distance, the list turned out to be longer and louder than anyone expected. Start with the atmosphere again. Since the beginning of the Industrial Revolution, roughly 1760, humans have been pumping gases into the atmosphere that do not belong there. Carbon dioxide concentrations have risen from about 280 parts per million to over 420 parts per million. That is a 50% increase in a gas that has been in rough equilibrium for hundreds of thousands of years. Methane concentrations have more than doubled. Nitrous oxide has climbed by roughly 20%. But those are naturally occurring gases. They could theoretically be explained by unusual geological activity. What cannot be explained is the next one. Chlorofluorocarbons, CFCs. These are molecules that do not exist anywhere in nature. They were invented by chemists in the 1930s for use in refrigerators, air conditioners, and aerosol cans. They were pumped into the atmosphere in quantities large enough to eat a hole in the ozone layer. And they have a spectral signature, a chemical fingerprint in the infrared that is unique and unmistakable. If you were an alien astronomer running a spectrometer on Earth's atmosphere from 100 light years away and you detected CFCs, you would not need any further analysis. CFCs cannot be produced by geology. They cannot be produced by biology. They can only be produced by industrial chemistry. Their detection in an atmosphere is a definitive, unambiguous technosignature. It means someone on the surface has built factories. Think about that. We accidentally left a chemical business card in our own atmosphere, one that says an industrial civilization lives here, and we did it without intending to. We were just trying to keep our food cold, and the technosignatures go beyond chemistry. A comprehensive study led by Macy Houston and Adam Shake at Penn State in the early 2020s calculated how far away each of Earth's technosignatures could be detected using only current Earth-level technology. The numbers are sobering. Planetary radar, the kind we use to map the surface of Venus and track asteroids, could be detected from 10,000 light years away by a receiver, as sensitive as ours. That is 10% of the way across the entire galaxy. The Deep Space Network signals we use to communicate with Voyager and other distant probes could be detected at about 60 light years. Even the ambient radio leakage from mobile phone towers. Not a deliberate broadcast, just the spillover from your cell phone conversations, could be picked up from just over 4 light years away. That is the distance to Proxima Centauri, the nearest star to our Sun. You are walking around on the surface of a planet that is advertising its own technological civilization in every frequency band, in every direction, at every moment, not deliberately, not with some carefully composed interstellar message, just by existing, just by running your infrastructure. You are the electromagnetic equivalent of someone who does not realize they have their car alarm going off. And this is just what we can calculate based on our own technology. A civilization 1,000 years ahead of us would presumably have instruments 1,000 times more sensitive. To them, we are not a faint signal buried in noise. We are a spotlight. And here is a detail that makes this even more uncomfortable. Our radio bubble is actually getting quieter. In the early decades of broadcasting, we used high-power analog transmitters that leaked enormous amounts of energy into space. AM radio towers, early television stations, military radar systems. These were loud, wasteful, and gloriously detectable. But as our technology has matured, we have shifted to digital signals, fiber optics, satellite-based communications, and directional beaming, all of which leak far less energy into space. Our modern communications infrastructure is, ironically, harder to detect from a distance than our 1950s television broadcasts were. Think about what this means. There may be a window, a brief period in a civilization's technological history when it is maximally visible. After that window, it goes quiet. Not because it dies, because it gets smarter. It switches from broadcast to narrowcast, from analog to digital, from leaky to efficient. And from the outside, that transition looks exactly like a civilization going dark. If other civilizations follow the same arc, then the galaxy could be full of advanced societies that are electromagnetically invisible to us. Not because they are hiding, but because they went through the loud phase and came out the other side. We are still in the loud phase. We are the teenager blasting music from the car with the windows down, and we are about to roll up the windows. The question is, did anyone hear us while the windows were open? But here is the thing that changes this from a curiosity to a crisis. It is not just that we are detectable. It is that we are detectable right now, at a moment when we are actively changing the spectral fingerprint of our planet in real time. An observer who was monitoring Earth's atmospheric signature over the last 200 years would have watched the chemical balance that held for millennia suddenly, rapidly begin to shift. New molecules appearing, old ratios destabilizing, a biosignature that was stable for billions of years starting to flicker. From the outside, that does not look like progress. That looks like a patient whose vital signs just started going erratic. This brings us to the next piece of evidence. And it is about who might be reading those vital signs. Evidence 4. The transit shadow. Earth eclipses the Sun on a schedule that reveals everything. The most successful method humanity has ever developed for finding exoplanets is the transit method. When a planet passes between its host star and a distant observer, the star's light dims by a tiny measurable amount. That dip in brightness tells you a planet is there. How deep the dip is tells you how big the planet is. How often the dip repeats tells you the orbital period. And when you analyze the starlight that filters through the planet's atmosphere during the transit, you can read the chemical composition of that atmosphere. This is how we found thousands of exoplanets with the Kepler Space Telescope. This is how the James Webb Telescope is currently characterizing exoplanet atmospheres. This is, right now, the primary technique we use to search for biosignatures on other worlds. But here is the thing about the transit method. It works in both directions. Earth passes between the Sun and distant stars on a regular schedule. From the vantage point of those stars, Earth creates a tiny, periodic dimming of the Sun's light. Every year, like clockwork. And that dimming carries information. As Earth's atmosphere passes in front of the Sun during a transit, starlight filters through it, picking up the chemical fingerprints of every gas in our atmosphere. Oxygen, methane, carbon dioxide, water vapor, nitrogen, the CFCs we talked about, the nitrous oxide, everything. Any civilization that has developed transmission spectroscopy, the exact same technique we are using right now, could read Earth's atmosphere during one of these transits. They would see the biosignatures. They would see the technosignatures. They would know with certainty that the third planet in this system is alive and industrialized. And Kaltenegger and Faherty's 2021 study mapped exactly which stars are in the right position to see this. They called it the Earth Transit Zone, the thin strip of sky as seen from Earth, where other stars would see our planet cross the face of the Sun. Using data from the Gaia Observatory, they identified 2,034 star systems within 326 light-years that passed through this zone over a 10,000-year window centered on the present day. Some of those systems have been watching our transits for thousands of years. The exoplanet Ross 128b, about 11 light-years away, was in the right position to see Earth transit for 2,158 years, starting roughly 3,000 years ago. It lost its vantage point about 900 years ago. Others are about to enter the window. Teegarden's star, about 12.5 light-years away with 2 known Earth mass planets, will begin seeing our transits in 29 years. And the TRAPPIST-1 system, 45 light-years away, hosting 7 Earth-sized planets with 4 in the habitable zone, will enter the Earth transit zone in 1,642 years. Once it does, observers there will have 2,371 years of continuous observation. Think about what this means. We have been studying TRAPPIST-1. We have pointed the James Webb Telescope at it and read the atmospheric chemistry of its planets. We are trying to figure out if any of them are habitable. And in 1,642 years, if anyone is living on one of those planets, they will be able to do the exact same thing to us. They will look at our star, watch it dim slightly every 365 days, analyze the light that passes through our atmosphere, and read the chemical history of our planet. And here is a detail that deepens this considerably. The transit method does not just provide a snapshot. It provides a timeline. If an observer has been watching Earth transit for thousands of years, they have a historical record of our atmospheric chemistry. They would have seen the oxygen-methane balance hold steady for centuries. Then, starting roughly 250 years ago, a blink of an eye in geological terms, they would have seen carbon dioxide begin to climb. They would have seen methane spike. They would have seen novel compounds appear. Compounds that had never existed in that atmosphere before. An observer with thousands of years of transit data would not just know that Earth is alive and industrialized. They would know when we industrialized. They would know the rate at which we are altering our own atmosphere. And they would be able to calculate with some precision how long we can keep doing this before the system destabilizes. They would have a better understanding of our trajectory than we do, because they would have the data without the politics. As Kaltenegger herself put it, from the exoplanet's point of view, we are the aliens. That is not a metaphor. That is geometry. We transit. We are detectable. We have been detectable for longer than our species has existed, and we will become detectable to new systems continuously as stars drift in and out of the transit zone. And here is the part that most people miss about the transit method. It does not just tell you a planet is there, it tells you what the planet is like. During a transit, the atmosphere acts as a filter. Each gas absorbs specific wavelengths of light, leaving a chemical fingerprint in the starlight that passes through. If you have a good enough spectrometer, and we are building them right now, you can identify individual molecules. You can determine whether the planet has water, whether it has an ozone layer, whether its atmospheric chemistry is in equilibrium or out of it. During an Earth transit, an observer would see something that does not exist on any other known planet. They would see an atmosphere dominated by nitrogen and oxygen, with traces of methane, nitrous oxide, ozone, water vapor, and carbon dioxide. They would see a chemical profile that is violently out of equilibrium. Oxygen and methane coexisting where thermodynamics says they should not. And if they were looking during the last 200 years, they would also see the signature of chlorofluorocarbons, compounds that no natural process can produce. In other words, during a single transit observation, an alien astronomer could determine 3 things about Earth. It is alive, it has industry, and its industry is altering its own atmosphere. 3 data points, 1 observation, and they would not need to guess about any of it. Now compare that to what we have been doing. We have pointed the James Webb Telescope at planets around other stars and strained to detect hints of carbon dioxide or methane in their atmospheres. We celebrate when we find ambiguous traces of molecules that might be consistent with life. And here we are, a planet that would light up on any competent survey, wondering why nobody has called. The answer might not be that they have not seen us. The answer might be that they saw us a long time ago and made a decision about what to do with that information. You are on a planet with a scheduled broadcast, and the broadcast says, something is alive here. Something is changing the chemistry. Something is industrialized. The question that sits at the center of all this is not whether anyone can see us. It is what they would do about it. Evidence 5. The Fermi paradox inverted. The silence is not absence. It is protocol. For 65 years, the Fermi paradox has been framed as our problem. Where is everyone? Why can we not find them? The assumption has always been that we are the searchers and they are the ones who should be visible. That the silence needs an explanation that revolves around them. But what if we have the roles reversed? Consider our own search. Project Ozma, the first modern SETI experiment, was conducted by Frank Drake in 1960. He pointed a radio telescope at two nearby stars and listened for 150 hours. Nothing. Since then, the search has expanded vastly. Project Meta at Harvard, led by Paul Horowitz, scanned 8.4 million frequency channels simultaneously through the 1980s and 1990s. Project Serendip at UC Berkeley has been passively listening since 1979, piggybacking on other observations. And in 2016, Russian tech billionaire Yuri Milner committed $100 million to Breakthrough Listen, the most comprehensive search in human history, using the Green Bank Telescope in West Virginia, the Parkes Telescope in Australia, and the Meerkat Array in South Africa. It covers frequencies from 1 to 10 gigahertz, scanning 1 million of the nearest stars and 100 of the nearest galaxies. The result, after all of that effort, is one anomaly. The WOW signal, August 15, 1977. A 72-second burst at 1420 megahertz, the hydrogen line, exactly the frequency physicists had theorized an intelligent civilization would use. Astronomer Jerry Ehman circled it on his printout and wrote, "Wow," in the margin. It has never been explained. It has never repeated. It remains the only time the phone rang, and whoever was on the other end hung up before we could answer. One anomaly in 65 years. One. Now flip the perspective. If a civilization more advanced than ours has been monitoring our system, they have had 2.4 billion years of atmospheric biosignatures to study. They have had 125 years of radio leakage. They have had 80 years of nuclear detonation signatures. Above-ground nuclear tests produce electromagnetic pulses that are detectable at interstellar distances and are unmistakably artificial. From their perspective, we are not a mystery. We are a well-documented case study. The only mystery is what to do about us, and this is where the zoo hypothesis enters the conversation. In 1973, MIT radio astronomer John Ball published a paper proposing exactly this. Advanced civilizations know we are here. They have known for a long time, and they have collectively decided not to make contact. Not because they cannot, because they choose not to. The same way a wildlife researcher observes a newly discovered species without interfering. Ball's hypothesis was speculative when he published it. But here is what makes it harder to dismiss now. There is an official protocol for what happens if SETI detects a confirmed extraterrestrial signal. It was developed by the International Academy of Astronautics, and one of its central provisions is this: no response is to be transmitted without broad international consultation and consensus. We, the civilization that is actively searching for others, have pre-built a quarantine procedure into our own response plan. We have decided in advance that the appropriate reaction to contact is to stop, convene, and not reply without global agreement. Think about the logic here. We recognize that contacting a civilization you do not understand is risky. We have enshrined that recognition in formal protocol, and we assume that we are the only species in the galaxy smart enough to have arrived at that conclusion. Every argument we make for why we should be cautious about contact is an argument that a more advanced civilization would have made millions of years before us, with better data, more experience, and more at stake. Mikhail Vasilev formalized this in 1988. He called it the quarantine hypothesis. A mature civilization manages contact with younger ones conservatively. Not out of malice. Out of the same logic we apply when a biologist studies a newly discovered ecosystem. You observe before you intervene. You wait for the subject to reach a threshold of maturity before you introduce yourself. And this raises a question that is almost too uncomfortable to ask directly. What threshold are they waiting for? Is it technological? Wait until they achieve interstellar travel on their own. Is it ethical? Wait until they have resolved their internal conflicts. Is it existential? Wait until they have survived the dangerous early period of technological civilization. The period where a species is smart enough to split the atom, but not yet wise enough to guarantee it will not use the results on itself. There is a darker version of this logic that we need to address. The Chinese science fiction writer Liu Cixin formalized it in his novel The Three-Body Problem, and in 2023, researchers at the University of Bath published a mathematical model exploring it. It is called the dark forest theory. The argument goes like this. The universe is a dark forest. Every civilization is a silent hunter moving through the trees. And the first rule of survival in a dark forest is this: do not reveal your position. Because any civilization that announces itself to the forest becomes a target for every other civilization that is strong enough to eliminate it. In a universe where resources are finite, distance creates delay and intentions cannot be verified. The rational strategy for every advanced civilization is the same. Stay quiet and eliminate anyone who does not. This is the nightmare version of the silence. Not that nobody is listening, but that everyone is listening, and the reason nobody talks is that talking gets you killed. If the dark forest theory is correct, then our radio bubble is not a bonfire in a friendly campground. It is a flare fired into a war zone. And we have been firing flares for 125 years. But here is why I think the dark forest theory, while logically coherent, is probably not the dominant explanation. If it were true, we should already be gone. We have been electromagnetically visible for over a century. The speed of light is the speed of information. Any civilization within 62 light years could have detected us by now and had time to respond. We are still here. Either no one is close enough, or the dark forest is not as dark as the theory suggests. The more likely explanation, and the one supported by our own behavioral parallels, is the simpler one. Contact management. Observation protocols. The same logic we apply to uncontacted peoples, to newly discovered ecosystems, to any system that is complex enough that interfering with it might cause more harm than watching it. We have had nuclear weapons for 80 years. We have had synthetic biology for 2 decades. We have had advanced artificial intelligence for less than 10. Robin Hansen's 1998 paper on the Great Filter argues that civilizations which develop powerful technologies frequently destroy themselves before expanding beyond their home system. If that is the filter, if the test is, can you survive your own inventions, then we are in the middle of the exam right now. By the Lindy effect, the statistical principle that predicts the expected future lifespan of something based on how long it has already existed. Our technological civilization is in its infancy. We have barely proven we can survive a century of our own power. If contact requires clearing that bar, the silence is not mysterious. It is a waiting room, and we are sitting in it right now. And there is another dimension to this that makes the silence even more layered. In 1948, Claude Shannon published his foundational work on information theory. One of his central results, a mathematical theorem, not a hypothesis, is that a perfectly compressed signal is statistically indistinguishable from random noise. Think about what that means. The most efficient way to transmit information produces output that looks, to anyone without the right decoder, exactly like static. We have been scanning for structured signals, regular pulses, mathematical sequences, messages in a bottle. But a civilization a million years ahead of us would not be broadcasting in patterns we would recognize. Their communications would be maximally compressed, maximally efficient, and by Shannon's theorem, maximally invisible to our instruments. We would not detect them as signals. We would detect them as background noise, and we would filter them out. John Smart developed this argument formally in 2012. The implication is genuinely disturbing. We could be swimming in signals right now and have no way of knowing. Our search strategy assumes that other civilizations want to be found and are willing to waste energy broadcasting inefficiently just so that younger civilizations can pick up the call. That is an assumption about their intentions, not a fact about physics. And there is one more layer. Claude Lefebvre at the Paris Observatory calculated in 2018 that even with millions of civilizations in the galaxy, the probability of 2 civilizations being alive, technological, and transmitting at the same time, within detectable range of each other, is less than 0.001%. The distances are too vast and the lifespans too short. 2 civilizations might exist a few thousand light years apart, but if one arose 1,000,000 years before the other and lasted only 10,000 years, they would never overlap. The silence is not necessarily the sound of an empty galaxy. It might be the sound of a full galaxy where everyone showed up at different times to a party that lasts forever, and most of the guests have already left or have not yet arrived. And we are at the party right now, alone in the room, wondering where everyone is, not realizing that the room itself is watching to see what kind of guests we turn out to be. But here is where the investigation takes a turn, because the question of whether anyone has been watching is theoretical. The question of whether anything has been here is not. Evidence 6. Oumuamua. The visitor we watched leave on October 19, 2017, the Pan-STARRS 1 telescope in Hawaii spotted a faint, fast-moving object tumbling through the inner solar system. At first, astronomers classified it as a comet, then reclassified it as an asteroid. But as they tracked its trajectory with increasing precision, they realized something unprecedented. This object had come from outside the solar system. It was traveling on a hyperbolic orbit, meaning it was not gravitationally bound to our Sun. It had entered our system from the direction of the constellation Lyra, swung past the Sun at roughly 26 kilometers per second, and was heading back out into interstellar space. They named it Oumuamua, Hawaiian for scout or first messenger from afar. It was the first confirmed interstellar object ever detected passing through our solar system. And the more data they collected, the stranger it became. First, the shape. Based on its light curve, the pattern of brightness changes as it tumbled. Astronomers estimated that Oumuamua was extremely elongated or disc-like, at least 10 times longer than it was wide, with a cross-section roughly 100 meters across. No natural asteroid or comet in our entire solar system catalog has those proportions. Asteroids are typically lumpy, irregular, potato-shaped. Oumuamua looked like something else. Then came the movement. As Oumuamua left the inner solar system, it accelerated. Not by much. About 5 millionths of a meter per second squared. But it was measurable. In 2018, Marco Micheli and colleagues published their analysis in Nature, confirming a non-gravitational acceleration that was inconsistent with gravity alone. Now, comets do this. When a comet passes near the Sun, its ice sublimates. It goes directly from solid to gas, creating jets that push the comet slightly off course. This is called outgassing, and it produces exactly the kind of non-gravitational acceleration Micheli measured. The obvious explanation was that Oumuamua was an icy body undergoing outgassing. But there was a problem. Oumuamua had no tail, no visible gas, no dust coma. The Spitzer Space Telescope specifically looked for thermal emissions that would indicate sublimating ice and found nothing. Whatever was pushing Oumuamua, it was not behaving like any comet we have ever observed. In November 2018, Avi Loeb, then chair of Harvard's astronomy department, and Shmuel Bialy published a paper in the Astrophysical Journal Letters proposing an alternative. They calculated that the observed acceleration was consistent with radiation pressure, the force of sunlight, acting on a thin, flat surface with a very low mass-to-area ratio. In other words, a light sail. A piece of technology designed to be propelled by the pressure of starlight. This is not science fiction. The Japanese space agency, JAXA, successfully deployed a solar sail called Icarus in 2010. The Breakthrough Starshot initiative is currently designing light sails to send tiny probes to Proxima Centauri at 20% of the speed of light. We are building this technology right now. And Loeb's point was specific. If we are developing light sails, then any civilization that preceded us by even a few centuries would have had them already. And a derelict light sail, drifting through interstellar space for millions of years, after its mission was complete or its civilization was gone, would look exactly like what we observed. Thin, flat, reflective, accelerating under solar radiation, no propulsion system, no tail, no coma, just a surface, catching light, moving through our system on a trajectory that brought it close to our star and then sent it on its way. Loeb later expanded his argument in a book titled Extraterrestrial, published in 2021. His core claim was not that Oumuamua was definitely artificial. His claim was that the scientific community dismissed the artificial hypothesis too quickly, not because the evidence ruled it out, but because the implications made people uncomfortable. And that discomfort, he argued, is not a scientific reason to reject a hypothesis. You do not get to discard a possibility because you do not like what it means. The scientific community pushed back strongly. Subsequent papers proposed that Oumuamua might be a hydrogen iceberg, a nitrogen ice fragment from a Pluto-like body, or an unusually porous fractal object with extremely low density. Each of these explanations has its own problems. Hydrogen ice is almost impossible to form in known astrophysical environments and would sublimate rapidly in interstellar space. Nitrogen ice fragments of the required size are statistically unlikely, and the fractal structure hypothesis still does not fully account for the specific magnitude and direction of the acceleration. This is where certainty ends. We cannot know what Oumuamua was. We did not have the technology to intercept it. By the time we understood what we were looking at, it was already too far away to reach. We watched it enter our system, pass through the inner planets, accelerate without visible propulsion, and leave. The entire encounter lasted weeks. But here is what we do know. In 2019, a second interstellar object was detected, 2I/Borisov, a comet with a clear tail and typical cometary behavior. It behaved exactly the way we expected an interstellar comet to behave. Oumuamua did not. The existence of Borisov shows us what a normal interstellar visitor looks like. And Oumuamua was not that. Science stops here. But consider for a moment what this encounter looked like from a narrative perspective. An object from outside our solar system entered without announcement. It took a trajectory through the inner system. It passed close to Earth. It accelerated in ways we could not explain, and it left before we could study it in detail. If you were designing a passive flyby of a young technological civilization, one that had recently developed telescopes but had not yet developed interstellar travel, this is roughly what it would look like. You would not stop. You would not transmit. You would not make contact. You would just pass through close enough to observe and leave. A reconnaissance mission that is indistinguishable from a natural event unless the target civilization is paying very close attention. And we were paying attention, barely. Oumuamua was discovered on its way out. We caught it in our peripheral vision as it was already leaving. If it had arrived on a slightly different trajectory, Or if Pan-STARRS had not been scanning that patch of sky that night, we would have missed it entirely. It would have passed through our solar system, done whatever it was going to do, and left without us ever knowing it was there. How many others have done exactly that? How many interstellar objects have passed through this system in the last 4 billion years without being detected? We have only had the technology to spot these objects for about 2 decades. The universe has been sending things through our neighborhood for billions of years. We have been watching for roughly 0.0000005% of that time. The doorbell rang. By the time we got to the door, the visitor was already walking down the street. And we are still standing in the doorway, trying to decide if we imagined it. And the most unsettling question is not what Oumuamua was. It is this. If it comes back, or if another one arrives, would we even know what to do about it? We have no interception capability. We have no probe fast enough to catch an interstellar object on a flyby trajectory. We can barely track them. We are a civilization that knows, for the first time, that objects from other star systems pass through our home regularly, and we have no capacity to do anything about it except watch. That is the position we are in. We are detectable, we are visited, and we are helpless to respond to either fact. But there is one more piece of evidence, and it is the one that makes all the others feel different. Evidence 7. The genetic code. A message written in every cell of your body. This is the evidence that sits the most uncomfortably. In 2013, 2 physicists named Vladimir Szczerbak and Maxim Makukov at the Fesenkov Astrophysical Institute in Kazakhstan published a paper in the journal Icarus. The paper was titled "The Wow Signal of the Terrestrial Genetic Code," and its central argument was one of the most provocative claims ever made in a peer-reviewed scientific journal. They did not analyze DNA sequences. They analyzed the code itself, the mapping system, the rules that determine which 3-letter combinations of nucleotides, called codons, correspond to which amino acids. This mapping is universal. Every living thing on Earth, from the simplest bacterium to the largest whale, from the mold on your bread to the neurons firing in your brain, uses the same code. The same 64 codons, the same 20 amino acids, the same start signals, the same stop signals. It has been this way for at least 3.5 billion years. Let me make sure you understand how strange this is. Think about human languages. There are roughly 7,000 languages spoken on Earth right now. They use different sounds, different alphabets, different grammars. They arose independently in different places and diverged over time. That is what you would expect from any information system that evolves naturally. Variation, divergence, regional dialects that eventually become mutually unintelligible. The genetic code does not do this. It is the same in a bacterium living in a hydrothermal vent on the ocean floor and in a bird flying over the Arctic. It is the same in a fungus breaking down wood in a Brazilian rainforest and in the cells of your retina converting light into electrical signals right now. 3.5 billion years of evolution, countless trillions of individual organisms, every environment on Earth from boiling acid pools to frozen Antarctic rocks, and the code has not diverged. Not once. Not even slightly. There are minor variations. A handful of organisms use slightly different codon assignments, but these variations are trivially small, usually a single codon reassigned, and they all clearly derive from the standard code. They are dialects, not different languages. The core architecture has been locked in place since the very beginning, and that is where Shao-Cherbak and Makukov's analysis enters. They were not looking at the sequences, the specific genes, the specific proteins. They were looking at the code itself, the assignment table, the rules. Shao-Cherbak and Makukov found that this code contains mathematical patterns that are, in their words, far too precise to be attributed to natural processes. Specifically, they identified patterns involving the number 37 and its multiples embedded in the nucleon counts of amino acids and in the organizational structure of the code itself. They found symmetries, error-correcting features, and what appeared to be a decimal notation system within the codon assignment table. Let me be clear about where this sits in the scientific landscape. This is contested, deeply contested. Most molecular biologists would argue that natural selection is entirely capable of producing mathematical regularities, because when physical and chemical constraints narrow the space of possible configurations, patterns emerge naturally. The genetic code is not arbitrary. It has been shaped by billions of years of optimization, and optimization, by its nature, produces structure that can look designed. But Cherbak and Makukov's argument is specific. They are not claiming that the code is structured. Of course it is structured. They are claiming that certain mathematical features in the code serve no known biological function. They are decorative, embedded, like a watermark in currency. Present not because the system needs them to operate, but because someone put them there on purpose. Now, this is where you need to decide how far out on this limb you are willing to walk. The mainstream position is that these patterns are artifacts of natural chemical constraints and do not require an intelligent designer. That is a defensible position. It is probably the correct one. But here is the part that does not require any speculation at all. The genetic code is universal. It has been universal for at least 3.5 billion years. It has survived 5 major mass extinction events, including the one that killed the dinosaurs 66 million years ago. It has persisted through ice ages, supervolcanic eruptions, asteroid impacts, and the complete transformation of Earth's atmosphere. And it is identical in every organism that has ever been tested. No technology that humans have ever created comes close to this level of durability. No book, no building, no digital storage system, no carved monument. The genetic code has been running continuously without interruption for 3.5 billion years. It is the most durable information storage system in the known universe. If you wanted to leave a message that would last forever, a message that would replicate itself, spread across an entire planet, survive every catastrophe the planet could throw at it, and be present in every living thing on the surface, you would put it in the genetic code. You would encode it not in the sequences. which mutate and change and evolve, but in the code itself, which does not. The mapping table, the rules, the architecture, and every cell in your body, all 37.2 trillion of them, would be carrying that message right now. This is where certainty ends, and where the real investigation begins. Because whether or not the genetic code was designed, the code itself is a fact. It is universal. It is ancient. It is the most conserved piece of information on this planet. And it is inside you. It is what makes you you. And it has been broadcasting its own existence through the biology of every organism on Earth, for longer than the continents have been in their current positions. You are a walking library, and you have never opened the book. And here is where this connects back to everything else. Remember the Murchison meteorite. Remember the Ryugu samples. The building blocks of the genetic code, the nucleobases, the amino acids, are floating around on asteroids. They were present before Earth formed. They are present on bodies that have never been alive. The chemistry is universal. The code is universal. And the code is the same in every organism on Earth, which means it was established once, very early, and never changed. That raises a question that Francis Crick himself asked. Crick, who won the Nobel Prize in 1962 for discovering the structure of DNA, published a paper in 1973 with chemist Leslie Orgel, proposing what he called directed panspermia, the idea that life on Earth was deliberately seeded by an intelligent civilization from elsewhere in the galaxy. He looked at the same code we are discussing right now and said, in effect, this does not look like it started here. Crick was not a crank. He was one of the most important scientists of the 20th century. And he looked at the genetic code, at its universality, at its early establishment, at the speed with which it appeared on a cooling planet. And he thought, this looks delivered, not evolved. Most biologists disagree, and they have good reasons. The code's universality can be explained by common descent from a single origin. Its early establishment can be explained by the rapid colonization of Earth by microbial life once conditions stabilized. Its mathematical structure can be explained by the physics of nucleotide amino acid interactions. But even the skeptics acknowledge that the genetic code is one of the deepest unsolved problems in biology. We do not know how it originated. We do not know why this particular mapping of codons to amino acids was selected over the vast number of alternatives. And we do not know whether the same code would arise on another planet with the same chemistry, or whether it is specific to whatever happened on Earth 3.8 billion years ago. What we do know is that you are carrying it, right now, in every cell, and it has been running without interruption since before the continents formed. It is older than mountains. It is older than the ocean basins. It is older than the moon's current orbit. And it is inside you, right now, spelling out the instructions for the only confirmed instance of intelligence in the observable universe. That is either the most ordinary thing in the cosmos, a predictable outcome of chemistry in the right conditions, or it is the most extraordinary thing that has ever happened. There is no middle ground. And that brings us to the last piece of evidence, the one that ties everything together, the simplest one, and maybe the hardest one to sit with. For 60 years, the search for extraterrestrial intelligence has been based on a single, unexamined assumption. That alien means other, something distant, something foreign, something fundamentally different from us. The entire framework presupposes that we are the searchers and they are the searched for, that we are ordinary and they are exotic, that the anomaly is somewhere out there and we just need to find it. But when you lay out all the evidence, the atmospheric biosignature, the asteroid chemistry, the technosignatures, the transit shadow, the quarantine logic, the interstellar visitor, the durability of the genetic code, a different picture emerges. And it is a picture that the SETI community itself has been slowly, reluctantly coming to terms with. In 2018, astronomers at Penn State attempted to quantify how much of the cosmic haystack we have actually searched. The analogy Jill Tarter, co-founder of the SETI Institute, has used is illuminating. If the total volume of signal space we would need to search, every frequency, every direction, every modulation type, every time window, were the volume of Earth's oceans, then the amount we have actually searched in 60 years is roughly equivalent to a hot tub. We have scooped a cup of water from the Pacific and noted the absence of fish. But that analogy cuts both ways, because while we have barely searched the ocean, we have been swimming in it the entire time. We are not outside the haystack looking in. We are inside it. We are part of it. And the question that nobody in the SETI community seems willing to state plainly is this: what if the most detectable thing in the haystack is not a needle hidden somewhere in the distance? What if it is the hay itself? What if it is us? From the perspective of any civilization outside our solar system, here is what Earth looks like. A planet with a persistent oxygen-methane disequilibrium in its atmosphere. A biosignature that has been active for over 2 billion years. A surface modified by technology in ways that produce synthetic chemical signatures detectable across light years. An expanding sphere of electromagnetic radiation that has washed over at least 2034 star systems. A periodic transit signal that reveals the chemical composition of the atmosphere to any observer in the transit zone. Organic chemistry on asteroids throughout the system, with only one body where that chemistry crossed the line into self-replicating life. And one species, out of the millions on the surface, that has developed the capacity to wonder whether anyone else is out there. That species is not the searcher. That species is the signal. We have been looking outward, past the moon, past Mars, past the heliopause, past the Oort cloud, into the depths of interstellar space, searching for something anomalous, something that does not fit, something that would confirm we are not alone. And the most anomalous thing in this entire data set has been right here the entire time, on the surface of the third planet, looking through a telescope, expecting to see something strange, and not recognizing that the strangest thing in the data is the one holding the telescope. Let me put this as plainly as I can. We have been searching for intelligence in the cosmos. We define intelligence as the ability to manipulate the environment, to communicate, to build structures that persist. And by every one of those criteria, Earth is the single most intelligent-looking object in the known universe. No other planet we have observed shows atmospheric chemistry modified by technology. No other planet produces electromagnetic radiation in patterns that suggest artificial origin. No other planet has a transit signature that includes both biological and industrial markers. If an alien SETI program exists, if somewhere in the galaxy a civilization has built its own version of breakthrough listen, Earth would be their top candidate, not one of many candidates. Their top one. The planet, most likely, based on all available evidence, to host a technologically active civilization. They would not need to guess. The data would be unambiguous, and if they have been monitoring Earth for any significant fraction of the 2.4 billion years our atmosphere has been anomalous, they would have watched the entire show. The first oxygen, the first complex cells, the first multicellular life, the Cambrian explosion, the colonization of land, the rise of mammals, the emergence of a species that started modifying its own atmosphere and broadcasting electromagnetic radiation in every direction. They would have watched the whole thing, and they would be watching right now, because right now is the most interesting part. Right now is the part where the species either figures it out or does not. The search for extraterrestrial intelligence is a species looking into a mirror and not recognizing its own face. And that recognition, when it fully lands, does something to you. Because if we are the alien planet, if we are the thing that the rest of the galaxy, should it have eyes, would point at and say, that is the anomaly, then everything changes. Every assumption about our ordinariness collapses. Every comforting notion that we are one of many, a standard outcome of a standard process on a standard planet, evaporates. And what replaces it is not comfort. What replaces it is weight. If we are the anomaly, then what we do matters in a way that most people never think about. Every species we drive to extinction removes a line from the most complex biological text in the known universe. Every ecosystem we collapse simplifies the most sophisticated chemical system that any observer in the galaxy could detect. Every synthetic pollutant we pump into the atmosphere alters a spectral fingerprint that has been stable for billions of years. We are not just inhabitants of a planet. We may be the curators of the only confirmed living world in the observable universe. And we are modifying it, rapidly, without any plan, without any awareness of what it looks like from the outside. Imagine an alien astronomer who has been monitoring Earth's atmospheric signature over the last 200 years. They would have watched the oxygen-methane balance hold steady for millennia. And then, starting around 1760, they would have seen a spike. Carbon dioxide climbing, methane doubling, novel synthetic compounds appearing for the first time in the planet's 4.5 billion year history. Compounds that have never existed on this world before. From their vantage point, they would not see a civilization advancing. They would see a biological system in crisis. A planet whose chemical signature is destabilizing. An anomaly that might be resolving itself. either into a new stable state or into silence. And they would have no way of knowing which one it is. That is what we look like from the outside. A planet that has been biologically stable for billions of years, suddenly and rapidly rewriting its own chemical signature in ways that could go either way. A civilization at the exact inflection point where it either stabilizes and persists or burns through its own substrate and goes quiet, and that brings us back to the silence. If the silence is a waiting room, as the quarantine hypothesis suggests, then the question is not whether we are being watched. The question is what they are waiting to see. And the most logical answer, the one that every piece of evidence we have examined today points toward, is that they are waiting to see if we survive ourselves. Because a species that can produce synthetic molecules that no natural process has ever created is a species that has crossed a threshold. That threshold is the same one the great filter theorists describe. The moment where a civilization becomes powerful enough to alter its own planet, but not yet wise enough to do so sustainably. We are at that threshold right now, not in 1,000 years, not in 100. Right now. The atmospheric data says so. The biodiversity data says so. The nuclear arsenal says so. The artificial intelligence capabilities say so. And if contact requires passing that threshold, if the protocol for reaching out to a young civilization includes a clause that says, wait until they prove they can survive their own technology, then the silence is not a rejection. It is a test. You are sitting inside the test right now. And what does passing the test look like? Nobody knows. We have no examples. We have no species that has demonstrably survived the transition from planetary civilization to interstellar civilization. We have no manual, no precedent, no cheat sheet written by a species that made it through. Every civilization that has ever reached this threshold in the history of the galaxy has either passed it in silence, meaning we cannot detect their success, or failed it permanently, leaving behind nothing but a chemical residue in the rock of their home planet. We are writing the answer to the test right now. Every policy decision about carbon emissions is a line in the answer. Every choice about artificial intelligence governance is a line in the answer. Every nuclear weapon that remains active, every engineered pathogen that exists in a laboratory, every decision about whether to preserve or exploit the biosphere that sustains us. These are all lines in the answer to a test that determines whether the signal we have been broadcasting continues or goes dark. And if the quarantine hypothesis is correct, then someone is reading the answer as we write it. They are not grading on a curve. They are not offering extra credit. They are watching a young civilization do what young civilizations do, stumble through the most dangerous period of their existence. And they are waiting to see if we are the ones who make it through, or if we are another entry in a very long, very silent ledger of species that almost made it. And this is where the dread converts to something else. Because here is what is also true, and what the evidence also shows. You are the only known organism in the universe that can look at this evidence and understand what it means. Not just see the stars, not just feel the oxygen in your lungs, but understand the chemistry, model the physics, map the transit zones, read the nucleobases on asteroids, decode the patterns in your own DNA, compose the question, are we alone? And know, on some structural level, that the answer might be, we are the answer. No other species on this planet can do that. Not the dolphins, with their complex social structures and their 50 million year head start. Not the chimpanzees with their tools and their social politics. Not the octopuses with their distributed nervous systems and their ability to solve problems that would stump most mammals. They are alive. They are aware. They are intelligent in ways that deserve respect. But they do not have the cognitive architecture to understand what they are. You do. You are, as far as the data shows, the most sophisticated information processing structure that has ever existed in 13.8 billion years of cosmic history. Your brain contains roughly 86 billion neurons connected by 100 trillion synapses. More connections than there are stars in the Milky Way. And that network is capable of something that no star, no galaxy, no black hole, no cosmic structure of any kind has ever done. It can model the universe inside itself and ask questions about what it finds. Stars burn. Galaxies rotate. Black holes consume. They do these things because the laws of physics compel them to. They have no choice. They have no awareness. They are processes, not perspectives. You are the first thing in the known history of the cosmos that is both a process and a perspective, both a physical system and something that can stand outside that system and ask, why does this exist? What does it mean? Am I the only one asking? And that is not a comfort. That is a responsibility. The weight of it is real. It is not a metaphor. If we are the only minds in this region of the galaxy, and the evidence we have examined today suggests that we might be, then every decision we make about the future of this planet, this species, this biosphere carries consequences that extend beyond anything our political systems are designed to handle. Every extinction event we cause reduces the complexity of the only confirmed living world. Every ecosystem we simplify removes a thread from a tapestry that took 3.8 billion years to weave. Every year we spend accelerating carbon dioxide into the atmosphere is a year we spend destabilizing the spectral fingerprint that has been broadcasting our existence since before animals existed. And we are doing all of this while being watched, or at least while being watchable. The transit data says so, the atmospheric chemistry says so, the radio bubble says so. Whether or not anyone is actually watching is irrelevant to the fundamental point. We are visible. Our actions have consequences that extend beyond our planet, beyond our species, beyond our comprehension of what it means to be the anomaly in the data. Because if we are the aliens, if we are the thing that the rest of the galaxy would flag as anomalous, the thing that does not fit, the signal that stands out against the background noise of an otherwise silent cosmos, then what we do in the next century is not a local issue. It is not a political issue. It is not even a planetary issue. It is a cosmic issue. The only confirmed instance of the universe producing something capable of understanding itself is deciding right now, in real time, whether to continue existing. Traffic does not matter when you are thinking about that. Social media does not matter. The small anxieties that eat your afternoons do not matter. What matters is that something exists right now on the surface of a planet in the Orion Arm that can look at a rock from an asteroid and read the letters of its own genetic code written in the chemistry. That can look at a signal from 1977 and recognize it as the one time the phone rang. That can watch an object from interstellar space tumble through the solar system, accelerate without propulsion, and leave, and understand that it was the first visitor. And here is what changes when you carry this understanding with you out of this investigation and into the rest of your life. The sky looks different. Not metaphorically, literally. When you look up at night and see the stars, you are no longer looking at distant objects that have nothing to do with you. You are looking at the audience. You are looking at the observatories that could be, right now, pointed in your direction. Some of those stars have planets in the Earth transit zone. Some of those planets may have instruments capable of reading your atmosphere, and your atmosphere is telling them everything. The ground looks different too. When you walk outside, you are walking on the surface of the only confirmed living world. The soil beneath your feet contains more microorganisms in a single teaspoon than there are stars in the Milky Way. Each one of them is carrying the same genetic code that has been running since before the continents formed. You are standing on a biological engine that has been operating without interruption for 3.8 billion years. And you are the only part of that engine that knows what it is. That knowledge is the rarest thing in the universe. Not carbon, not water, not even consciousness. Knowledge, the specific, recursive, self-aware kind of knowledge that allows a collection of atoms to look at itself and say, I am here. I know I am here. And I know that knowing this is the most improbable thing that has ever happened. You are the alien. You have always been the alien. The search was never about finding something out there. It was about recognizing what is already here. And the most honest thing I can tell you is this. Personally, I no longer believe that the silence of the universe is empty. I think it is full. I think it is full of patience and observation, and the kind of deliberate restraint that only makes sense if you believe the thing you are watching is worth waiting for. Whether that belief is justified depends entirely on what we do next. And I want to sit with that for a moment, because what we do next is not an abstraction. It is not something that happens at a policy level, in a conference room, in a legislature, on a geopolitical stage. Those things matter. But they are downstream of something more fundamental. What we do next is determined by what you believe you are. If you believe you are an ordinary organism on an ordinary planet, then your choices carry ordinary weight. You live, you work, you raise your family, you die. The universe continues without noticing. But if the evidence we have examined today carries even a fraction of the weight it appears to carry, then you are not ordinary. You are a walking anomaly. You are the product of a chain of events so improbable that the universe has apparently only produced it once in this entire region of the galaxy. Every morning you wake up, You continue a biological process that has been running without interruption for 3.8 billion years. Every time you ask a question, any question about anything, you are doing something that no other known structure in the cosmos has ever done. And every time you look at the sky and feel something you cannot name, you are a piece of the universe becoming aware of itself, which may be the rarest event in the history of matter. And that changes the texture of your days if you let it. The morning commute is not just a commute. It is the universe's most complex information processing system, navigating a physical environment on the surface of the only confirmed living world. The argument you had with someone yesterday is not just an argument. It is two instances of the most improbable phenomenon in the cosmos disagreeing about how to use their time. The anxiety you feel about the future is not just anxiety. It is the universe worrying about whether the one thing it produced that can worry will survive long enough to justify the worry. You are not separate from the cosmos looking in. You are the cosmos looking at itself. And the fact that it can, that it does, that right now, through your eyes and your neurons and your awareness, it is processing its own existence, is not a small thing. It may be the biggest thing that has ever happened. The atoms in your hand were forged in a star that died before the Earth existed. The oxygen in your lungs was produced by organisms that have been running the same photosynthetic chemistry for more than 2 billion years. The nucleobases in your DNA were floating on asteroids before the solar system had planets. And the signal you are broadcasting, the electromagnetic noise, the atmospheric anomaly, the biological fingerprint, the whole screaming, improbable, beautiful mess of it has been visible to the cosmos for longer than you can imagine. You are not a small thing in a large universe. You are the universe's most visible feature, the one thing that does not fit. The anomaly in the data that any observer worth their instruments would circle and write a single word in the margin. And maybe the greatest paradox of all is this. We have spent 60 years pointing our telescopes outward, scanning the darkness for a signal, a shape, a sign that we are not alone. And the most important discovery of the entire search may not be something we find out there. It may be something we finally recognize right here. That the signal we have been searching for is the signal we have been sending. That the intelligence we have been hoping to detect is the intelligence that hopes. That the alien planet we dreamed of finding was always the one we were standing on. And if we survive, if we clear the threshold, if we make it through the dangerous century, if we figure out how to sustain the only confirmed biosphere in the observable universe, then something else happens. Something that the dread has been obscuring this entire time. If we survive, we become the ones who watch. We become the civilization that monitors younger worlds. We become the species that develops the protocols, that builds the observatories, that makes the decisions about when and whether to reach out. The silence does not end with us receiving a message. It ends with us becoming capable of sending one that is worth receiving. And that possibility, not the contact, not the aliens, not the signal from somewhere else. That possibility is the most important thing that has ever existed. Because it means the silence is not permanent. It means the empty room does not stay empty forever. It means that the first species to survive the filter gets to fill the silence with whatever it chooses. And right now, the only candidate for that species is you, sitting right here, breathing an atmosphere that has been screaming into the void for 2.4 billion years, carrying a genetic code that has survived every catastrophe this planet has ever thrown at it, broadcasting electromagnetic radiation in every direction, wondering if anyone is listening. Someone might be listening. But the more important question is, are you listening to what your own existence is telling you? Something is happening here, and it is you. Subscribing will not make the aliens arrive any faster. But it will help the signal reach other observers before the window closes. And I want to know, which piece of evidence from this investigation unsettles you the most? Is it the oxygen anomaly? The fact that Earth has been biochemically screaming for 2.4 billion years? Is it Oumuamua, the interstellar visitor we watched leave without understanding what it was? Or is it the mirror, the realization that the thing you have been searching for is the thing doing the searching? Let me know in the comments. And if you want to keep exploring the terrifying beauty of what we are, make sure to subscribe.